When we're alone, or when late-night conversations with friends get a bit fuzzy, we've all probably wondered or even argued about what was there before everything. Before the sky, before time, what was there? What was the real beginning of everything? What started all of this? Was it God? Or was it the Big Bang? Some of us can just live our lives without being bothered by these questions, because some of us might not think about it much. Some might even disbelieve the real physics evidence that came from the Big Bang. They might think it's all lies except what our parents and their parents believed, but some of us, on the other hand, are bothered deep inside, which makes us keep asking and asking what the real answer is. It's really hard to imagine a world before time existed, because even when we try to imagine it, we still use time and space as tools for thinking, but at that 0 point there was no space to move and no time to flow. There were no stars, no earth, no place for life, just emptiness, or maybe something even stranger than that. Then something happened. In science, this is called the Big Bang, the initial explosion that brought space and time into being. From a single dense hot point, the universe began to expand, not into space but creating space itself. For thousands of years, humans have looked at the night sky with wonder and many ideas about existence. In many cultures, the stars that shine every night were seen as eternal. In many parts of the world, many traditions understood time as a cycle. The sun rises and sets, seasons come and go, and life moves in a repeating pattern. In some other traditions, especially in Abrahamic religions, time actually has a beginning and an end, from creation to the end of the world. These two big ideas, whether the world is eternal or created from nothing, have been central to how humans understand existence. And in the middle of this clash of ideas, ancient Greek philosophy played an important role. One of its key figures, Aristotle, became central in arguing that the world was not created but is eternal. In everyday life, we do see that everything changes, but all those changes are always caused by something else. There is no change without a cause. So Aristotle concluded that this chain of cause and effect cannot go on without an unchanging starting point. Aristotle's view lasted for a very long time, even after the Greek world fell apart. When Greek philosophy was translated into Arabic and Latin, Muslim thinkers like Ibn Sina and Ibn Rushd, as well as Christian thinkers like Thomas Aquinas, tried to combine Aristotle's views with their religious teachings. But here's the paradox. Aristotle believed that the world was eternal, while Islam and Christianity taught that the world was created from nothing. Aristotle's view continued to influence even into modern times. In the 19th and early 20th centuries, many scientists still believed that the universe was static and eternal. But all that began to change in the early 20th century when a Belgian Catholic priest named George Lemaître, who was also a physicist and mathematician, proposed something amazing. He didn't come with a religious agenda, but with mathematical calculations based on Einstein's theory of general relativity. General relativity states that space and time are not just empty, passive containers, but something that can bend and change according to how matter and energy are spread out. When Lemaître applied the equations of general relativity to the cosmic scale, he found that his mathematical solutions pointed to an expanding universe. From that, he concluded that if the universe is expanding now, then in the past it must have been smaller, and if we go back far enough, then all the matter and energy in the universe must have come from one starting point, very dense, very hot, and very small. He called this idea the primeval atom hypothesis. At first, many scientists rejected this hypothesis. Even Einstein himself rejected it, not because his calculations were wrong, but because he didn't like the idea that the universe had a beginning. It's even ironic that the name Big Bang came from a mocking remark. When Fred Hoyle, one of the scientists who disagreed with this theory, called the idea of the universe's beginning a Big Bang in a mocking tone on a BBC radio broadcast, the name stuck and even became iconic. The world might have laughed at this idea at first, but evidence kept coming out. In 1929, an astronomer named Edwin Hubble saw that the light from distant galaxies seemed to shift towards red. This shift meant that those galaxies were moving away from us. Hubble also found that the farther away a galaxy was, the faster it was moving away. This showed that the universe is expanding. The space between galaxies keeps getting bigger, like the surface of a balloon being blown up, making the dots on it move farther apart. A few decades after the Big Bang theory was proposed, the strongest evidence came by accident. In 1965, two scientists named Arno Penzias and Robert Wilson were testing their large radio antenna. At that time, they heard a constant static or hiss that they couldn't explain. This sound came from all directions and wasn't from Earth. At first, they thought it was just technical interference, But after more analysis, the scientists realized that the sound was cosmic background radiation. This radiation is now very cold and weak, but it still fills all of space. These waves are the echo of the big explosion that was the beginning of the universe. With this evidence, the Big Bang theory became not just an idea, but the foundation of modern cosmology. But when everything was answered physically, the faith of some people, especially in the Western world, began to shake. They asked, where is God's role? For many, the emergence of the Big Bang theory was a turning point, a moment when religion began to lose its footing in the discussion of the universe's origin. If the universe could be explained as the result of measurable physical processes with the laws of thermodynamics, general relativity, and quantum fluctuations, then for them, there was no longer any room for God. However, behind the excitement about the universe's origin, there's a fact that's often missed. The Big Bang theory wasn't born from an atheist scientist but from a Catholic priest, George Lemaître. He wasn't just a religious person who happened to understand physics but a serious scientist, a graduate of MIT and a colleague of Einstein, who lived in a world of faith and science without feeling that the two had to cancel each other out. For Lemaître, understanding the laws of physics was not a threat to faith but an expression of awe at the incredible cosmic order. As Albert Einstein once said, science without religion is lame, religion without science is blind. Science without meaning can become cold, lose its way, and even be destructive. But religion that rejects reality, that closes its eyes to knowledge and turns away from the concrete world, can easily get stuck in dogmatic blindness. Today, the legacy of that conflict is still felt. Some people still think that the more we understand how the universe works, the clearer it becomes that we don't need God. But on the other hand, many also feel that scientific understanding of the universe's origin deepens metaphysical questions. If the universe indeed had a beginning, then the question of what caused it, why did it have to appear, and why can it be governed by certain laws? These questions remain unanswered. The Big Bang theory has radically changed how we understand the universe. For the first time in history, humans have a scientific model that can explain that the universe had a beginning. The further science takes us in understanding the universe, the more we realize that there are questions that are hard to answer. One question that often comes up is, what happened before the Big Bang? It's like asking what direction is north from the North Pole. We can imagine north from anywhere else on Earth except at the North Pole itself. And here's the limit. Physics no longer answers because cause and effect also need time. And without time there is no before, or that which causes something to something. But we don't stop there. We ask further. Where do these laws of physics come from? Did they appear with the universe? Are they part of the universe itself? Why is there something rather than nothing at all? Why must there be space where something can happen? Why must there be laws that allow for order? One of the figures who directly opposed this was the theoretical physicist Stephen Hawking. In his work, The Grand Design, Hawking stated that the universe does not need God to begin. With principles like the law of gravity and quantum mechanics, according to him, the universe could have spontaneously created itself from nothing. Quantum fluctuations, probabilistic vibrations in empty space, can give birth to particles, space, and even time without any interference. In the quantum world, vacuum space is not a passive empty space. This vacuum space always experiences energy fluctuations, which are continuous random vibrations. However, many philosophers criticize Krauss's approach because it's seen as blurring the philosophical meaning of nothing. In philosophy, nothing means total absence, without laws, without space, without potential. Physicist and mathematician Roger Penrose once stated that the fundamental laws of the universe appear to be very specific and precise, as if they were chosen from many possibilities. This now shows how precise the Creator's purpose must have been, which is with an accuracy of 1 in 10 to the power of 10 to the power of 123. This is an incredible number. One cannot even write it out fully. This is the precision needed to set the universe's entropy so that the second law of thermodynamics still applies, and so that stars and galaxies can form. In many modern arguments that reject the need for God's existence, the explanation often given is this: we don't need God because the laws of physics are enough. But such a statement holds a very big assumption. If those laws existed before the universe, then where did those laws come from? Who or what established them? Or are the laws of physics themselves a kind of God? Perhaps, as Paul Davies once said, science might be able to explain the world, but we still have to explain the laws it uses. Why those laws? Why not other laws, and why should there be laws at all? The laws of physics seem perfectly suited to allow for life. But where do these laws come from, and why do they have such a form? Why should the universe be governed by rational laws? And perhaps it must remain a mystery, because when we ask what those laws are, we are not just asking about physics.